Okay, one last way to look at how circuits operate, and it's actually a pretty handy tool. It's called equivalent resistance. And what this tool says is this, and it uses Ohm's law, but it says any circuit with basic stuff with ideal components can be broke down into a very simple circuit. So like I can make a circuit that's just this. This is a very simple circuit that has the same kind of characteristics as this one. Now, it may not have all the characteristics, but it'll have a lot of them. And the main thing is the current. I can easily use equivalent resistance to find the current. So this circuit, it has one resistor, and that value of that resistor is Req. And this is for this circuit, this would be 3 volts. So REQ, once again, guys, it's a way to simplify circuits. Like this circuit above, it looks maybe like a little bit challenging, but this circuit is the most fundamental circuit. It shouldn't be too difficult, and they both should behave pretty much the same. But you have to calculate your REQ, and calculating REQ is different for each circuit. So for series circuits, REQ equals the sum of all your resistors. So R1 plus R2 plus R3 dot 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 up to infinity. However many resistors you have. This one I only have 2, so it'd only be 2 of them. It would be 5 and 9. The REQ for this one would be 14 ohms. And for those of you guys who are math savvy, you want to think of another way to write this, you can say REQ equals the summation I equals 1 to n resistor i's. So that's a pretty cool way of thinking about it. So you could do that, and this is going to it just means add up all your resistors. For series circuits, it's very simple. So in this case, it's 5 plus 9, and that equals 14. Parallel circuits, on the other hand, finding REQ is a little bit much more annoying. So this same circuit again, once again, REQ does apply. Ohm's law, we can break it down, and we can say REQ, the same circuit can be made into this. Again, the same thing. Even though it's a parallel circuit, I can still make this simple circuit out of it by finding its REQ. Now you say, well, what's the point of this again? So guys, when like with this one, let's say I wanted to find the current to this circuit, I could just say this: the voltage equals I REQ. And this would be the voltage to this mythical equivalent resistance, and you'd say it's like 3 volts equals I times 14 ohms, and then you would say I equals 3 over 14, and it would be amps. And you'd say, whoa, 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 whoa. So that's just how you did it, and that's the equivalent resistance idea, and you can do that, and you will find out the current through that equivalent resistance, and also the current through the battery because it's a single path circuit. Yes, yes. Again, I'll say it very slowly. Once again, if you use equivalent resistance, you can find the current through this hypothetical resistor, but since it's a single path circuit, you also find the current through the battery. So it's a trick to find the current through the battery, and it's actually quite helpful. So let's go down and try it with this guy. So we can find the REQ, but the calculation is different for parallel circuits than before. So I'll show you what the formula is. 1 over REQ equals 1 over R1 plus 1 over R2 plus 1 over R3 dot dot dot. Um, we could say 1 over REQ equals the summation of 1 over R to the I equals 1 to the nth. And that's a cool way of writing it. So how would I do it for this one? Well, it's a little challenging. It's much more challenging than the other one. But you would say 1 over REQ equals 1 over, let me look at this again. It looks like it's 5 and 9. 5 plus 1 over 9. Common denominator is going to be 45. So it's going to be 9 45ths plus 5, not 5, yeah, 5 45ths equals 1 over REQ. So I get 14 45ths. So I get REQ equals because once again, I need to solve for REQ. So 1 over REQ, let's go slow, equals 14/45. But I'm not done because I need to inverse this. So what you end up getting is REQ equals 45 over 14 ohms. And then you can plug this into the V equals I REQ to find the current through this. And what we can do is we can say it's 45 over 14 ohms multiplied by my I, which is, I don't know my I, sorry, equals 3 volts. I can divide both sides by this, and I end up getting, geesh, this is going to be pretty crazy, 42 over 45 equals I, which I think I can factor this, because that's, oy vey. Uh, Maybe we should sit down and take a look at it on your own. But I hope this comes out to be right. I think that should be right. Let me bring up Excel and just do it real quick. 42 divided by 45. Was that the current we got last time? I do not know. I really hope so. Okay, guys. Well, thanks for listening. That's another way of looking at circuits is the REQ method. Once again, guys, the REQ method simplifies every circuit down to this. That we're going to deal with this in class. You can always simplify a circuit down to its REQ, and then you can find the current through that hypothetical resistor, and you can find the actual current through the battery, and then that gives you some other insight into hopefully doing some quicker problem solving. Okay, guys.